Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to another episode of the ARC Advisory Group Smart Cities podcast. I'm Eddie Fidler. I'm a transport analyst at ARC, and I'm thrilled to be joined by Alex Gruzen, the CEO of WiTricity. Hey, Alex.
Hey, Eddie. Thanks for having me here today.
Yeah, it's our pleasure. Thanks for joining. So maybe you can just start by telling us about your background, and then we'll get into WiTricity and your role there.
Sure. So from a background point of view, I'm originally a aerospace and aeronautical astronautical engineer, actually a rocket scientist. But I went on to have a career largely in the consumer electronics and PC industry. That was the bulk of my career, leading the notebook businesses at companies like Compaq and HP and then Dell. And in those years, as products became more and more mobile, like for example, I was leading the notebook business at HP when we first introduced Wi-Fi into notebooks. I mean, it's like a given. Everything has Wi-Fi now, but this was the days when we were first introducing Wi-Fi, and suddenly, in the course of about 18 months, we went from maybe 10-15% of our notebooks having this wireless data. Right, we all had to plug in Ethernet cables to suddenly it was sort of a given. Every single product we sold had Wi-Fi built in. Now, so there was wireless data. But we were still left with this one remaining cord, which was the power cord. And about six and a half years ago, I met the team at WiTricity. And I was really blown away by the technology that had been developed at MIT and had been built on and within the WiTricity to eliminate that last cord, to actually make products truly wireless, to move electric power, to be able to charge batteries without any wires. And so that's when I joined WiTricity as the CEO about 6.5 years ago. And we have been building our technology portfolio. And like any company that comes out of university, you have to accomplish two things. One, you have to advance the core technology itself. So for wireless power, solving things like how much power and how efficient will it be, and what distance can you move, and what frequencies do you operate at, and how do you get certified around the world? So sort of technology development. And then at the same time, you're looking for how do those capabilities match market needs and customer needs, and finding what's generally referred to as sort of product market fit. And so for us, what was really obvious was that we had something truly unique for charging electric cars, that the fundamental capabilities of WiTricity's wireless charging technology matched up with this opportunity in this growing market for electric vehicles. So the fact that you could have power at the same levels as if you plugged in. So no compromise on the charge rate, that we could be just as efficient as if you plugged in, that you didn't have to park particularly accurately, that you could be offset front and back and left and right and still move the right amount of power and still be just as efficient. Or that one fixed charger installed on the floor of your garage or even in the cement could charge any height of car. It could charge from a sports car to a sedan to an SUV. And so all of those things were sort of unique to WiTricity's technology and really fit the market opportunity. And the real question for the company was sort of like when were EVs really going to take off, right? We knew had something unique for EVs, but when was the market going to take off? And about 4 years ago, I think the landscape really changed. There was Volkswagen had their Dieselgate. I think governments around the world realized that diesel wasn't going to be the solution to hit carbon reduction goals. The cost of batteries started decreasing rapidly. I mean, so there was sort of this crossover where it went from consumer electronics being the largest consumer of lithium-ion battery capacity to suddenly, even at the small levels of EVs that are being sold today, EVs were suddenly the largest consumer of battery capacity in the world, and that's only accelerated since then. And so the cost came down on batteries, therefore the range on EVs went up. And I think Tesla showed the world that, if you built an attractive car with decent range, people would flock to it, right?
Yep,
so
they will come.
So all of these things have really, happened in the past, 4 years. And so as a company, while our core technology applies to many, many markets. I mean, our wireless charging technology, it's known as magnetic resonance, could work on small consumer devices, phones, hearing aids, medical devices that could be implanted in your body, all the way up to industrial robotics and drones. One thing that's important in any private sort of startup company is having focus and driving your technology to market. And so as a company, we believe we have many, many applications in the future for our technology. Right now, we're wholly focused on this opportunity with the automakers.
Right, as that sort of presented itself and become what it's becoming.
Well, I think we play an important role in mass adoption of electric cars. I mean, I think that, to be honest, we have to be honest that the most buyers of EVs today are still on the front edge. I mean, they're still mostly early adopters.
Yeah,
if you look
it's
at
not quite mass market yet.
Not yet, and so
it's not.
So I've been doing consumer electronics products for over 20 years, and changing consumer behavior is not easy. And we are used to, in our car ownership, being completely reactive, right? My tank is almost empty. I find a gas station in less than 5 minutes. It takes me less than 5 minutes to fill it up, and I'm on the road again. I don't have to think about it for 5 days, a week, or whatever till I have to fill up again.
Right.
Owning an EV, so that's totally reactive, right? Owning an EV, you have to be completely proactive. I have to think to charge. I have to contemplate, when's the last time I charged the car? Is my battery full? Do I have enough range to accomplish what I need to do today? And maybe a little extra for the things I don't even yet know I might have to do today. And that's just anxiety, right? And anxiety generally inhibits purchase behavior, right?
Right. It's supposed to be
people don't want to make
convenient.
that mistake. They don't want to get stuck.
It's supposed to be your tool, not a burden.
So our company, WiTricity, works directly with the automakers, right? And we also do direct market research. And what we hear is that this, while the range has been going up, there's still anxiety about, are there enough charging stations? I mean, the single largest purchase inhibitor for EV buyers today is not like, is the range enough, but just, is there enough infrastructure out there? And this idea that you have to sort of plan and find a place to charge. To reach the sort of mass market, to get 15-20% adoption of EVs, what we are working with the automakers to do is to make charging completely transparent. It's just something that happens in the background. You don't think about it. That you park your car and it just charges. It doesn't matter you came home with a bag of groceries or you have your kid in the car seat, in the back seat, and you never will have the situation where, I'll plug it in later and you forget to, and you come back to the car the next morning, you didn't charge, and you can't get to work.
Yeah.
Right?
Yeah.
So the car will always be fully charged. Whenever you come back to it, it will always have its full range. And we think that creates an opportunity to position EV ownership as not this sort of anxiety-filled thing, but actually a better experience than having an internal combustion engine car. That I've got 200-300 miles of range. 90% of the driving I ever do is inside that range. And if I have wireless charging, I will never have to think about the fact that it's an EV or the fact that there's a battery or the fact that there's a finite capacity, except for those few times when I'm, obviously less than 10% of what people do, which is when I'm on a road trip. I'm going to grandma's house, I'm going from LA to San Francisco, Boston to DC or whatever. And then you're going to need to pull over to the side of the road and do fast charging. So that high traffic corridor based high speed charging plug-in capability is important for EV adoption. You see a lot of investment taking place in sort of building that fast charging capability. But I fundamentally don't believe that that's how people should charge day to day. It's extremely expensive infrastructure. The cost of the power delivered at that rate is really high. And it puts stress on the cars and the battery systems.
The batteries, right.
So I think it's a necessary and important component of what will be the sort of EV ownership ecosystem, but I don't think it's is or should be the fundamental driver of people deciding to buy an EV.
This is what comes up all the time, is that it's not just it's a completely different animal, and how you interact with it just has to be completely different than with a fossil fuel vehicle.
And I think a lot of reflexes are kicking in, right? People are like, because I can fuel up my gasoline-powered car in 5 minutes, then that has to be the objective and the goal. And I feel that there's a bit of a fast-charging arms race taking place among the automakers to say, well, my car does it in 30 minutes. Well, my car does it in 20 minutes.
Right.
And if you do the math, that's an extraordinary amount of power to deliver. Like the power of 300 homes going into one person's car just at that point in time.
For a few dozen minutes.
So I think it's important. I think it's really ultimately will be for long distance. And my goal is to just make the day-to-day level 2 charging, which is what's practical for your home. It's kind of like all the power you could really get in your garage. Or it's what's practical for, 40, 50 parking spots at work, or at a hotel or whatever. I mean, all of that charging is really going to be level 2, which is, for the most part, the sweet spot is probably around 11 kilowatts of power, which is about 30 miles of range per hour of charging. So it's about making charging where you park really simple and transparent, and something that happens in the background.
And like a lot of things, level 2 is not glamorous. It's not, we hit 400 kilowatts. It's nothing like that. It's that the data show that adopters of EVs charge at home, in their garages, in their driveways.
And I'm trying to make that easier. I'm going to make that easier and more palatable.
And that's not a bad thing. I mean, like you're saying, as that becomes easier and easier, not that it's unbearably hard with a charging cable, but you can forget it. It can be a hassle. But the fact is, the easier that gets, you eventually never even have to think about fueling your vehicle. You park it, you walk away, you come back, with full battery. No gas station. It's not 20 degrees in the winter. You're standing out there for even just 5 minutes.
So I have a plug-in hybrid today, and I wish I had wireless charging on it. I don't yet. From a WiTricity point of view, we work directly with the automakers. So our focus is not on some, sort of aftermarket hack. It's about, integrating deeply into the car design.
Yeah.
And I have this plug-in hybrid, and when it snows, like I can't even open the door to my charging port. It ices up and freezes, and the car's designed in Sweden, right? So shouldn't happen.
Right. You have a driveway,
right?
I bet, not a garage, right?
So parked outside, and here in the Boston area.
Yep.
Right. So our technology, I don't care about snow or ice or it doesn't matter, right? You just pull into the parking spot, you're just going to be able to start charging. So we just want to make it really easy in every application. I think that what I've talked about so far has been really supporting and encouraging broad adoption of EVs. It's what we need for the environment, right? It actually is not just about being green or being conscious of carbon. Driving EVs are fun. Right? I mean, I'm a car guy. I'm a long-term car guy. I've rebuilt engines. I've owned vintage cars. I mean, I'm a car guy. I have been my whole life. I used to race cars. But driving electric cars, they're great. They're fun. They're sporty. The instant torque is fantastic.
Yeah.
And the cost of ownership in terms of maintenance and the cost of maintenance over the lifetime of the vehicle is way down, right? And so there's a whole bunch of economic benefits. They're beautifully designed and fun to drive, and it's great for the environment. So it's a win-win all around. I'm just trying to get rid of this anxiety about the whole new behavior of having to charge.
Right. People don't love to change. And all those economic benefits are why I want to get into the commercial use cases in a few minutes. Sure. But before we go there, you mentioned you don't call this inductive charging. You guys call this magnetic resonance. So can you just briefly explain what that means and how that's different?
Sure. And it's actually one of the key reasons why our technology really works in this application. So induction is a technology that's been around for a long time, right? And when you think about where we would see this in our lives, my electric toothbrush, for example, I stick it on a stand. It's got a peg, and it aligns it perfectly. If you think about a Samsung or an Apple phone that use a technology standard called QI, right? Which, if you place that phone in exactly the right spot, on the pad, and you don't have a thick case, it will charge, and that's induction as well. And what's characteristic of both the things I just described is that you've got two coils that had to be sort of in very close proximity and perfectly aligned.
Right.
And the innovation that took place with the research team in the physics department at MIT in mid-2000s and was demonstrated experimentally in 2007 was this idea of instead of these closely coupled coils where one coil is forcing a current in the other coil that's tightly matched, highly coupled and perfectly aligned. What the MIT team showed the world was that if you made each of these a resonator that had a harmonic frequency that was sort of naturally tuned to, that even little bits of energy could move between them, and between the coils, even if they were misaligned or at a distance. And it could be energy could be moved efficiently over that distance. And so those characteristics I described as being really important for a car to be able to move power at high power levels efficiently at a distance, even with offsets or different heights.
Right. It could be 6 inches removed. Right. It could be a foot.
It's uniquely possible when you make these high quality resonators that have a harmonic frequency, and despite other interferences and offsets and stuff, you keep them tuned to the same frequency. So in some ways, the way you think about pushing a kid on a swing, just little taps of energy could get my daughter swinging, really high amplitude on that swing. In the same way, because these have a resonance, then little bits of energy from one can move to the other and still create big impacts.
Can you go into that a little bit more? Just a little bit more. What is a resonator, and how do you control it?
So it's really, from an electronics point of view, it's having the proper combination of inductance and capacitance. And so in the coil, energy is going between stored charge, and magnetic field, and basically oscillating, and you can tune that to a particular frequency. Mm-hmm. And the net of it, though, is you will see a ground pad that has a large coil in it that's designed at a specific way to have effectively a harmonic frequency. And then you can have another pad on the car that is as well tuned to that same frequency. And if you were to think back our conversation about classic induction, the two coils need to be the exact same size, and they have to overlap and be perfectly aligned. But with magnetic resonance, they don't have to be the same size. You could have a small receiver on the car and a large one on the ground, right? Again, that fits the automotive application well.
Right.
What matters is that you're getting them tuned to the same frequency. And we have been working for nearly 8 years now with all the automotive standards organizations around the world to build a global interoperability standard around this technology. So groups like the Society of Automotive Engineers, the SAE, it's classic. When I give people examples like, where would they have heard of SAE? Like, well, you bought oil for your car. Right, it's like SAE 20-/50.
They build the standards for that.
Right, they build all the standards, right? So they do it for everything electronic on a car and for braking systems. And so the SAE
to
is
tune
driven
the
a global standard for both the design of the systems, the frequencies we operate, the sizes, the permissible distances and heights, and the control mechanisms, like the wireless handshake that takes place between them to say, hey, I'm here, I'm ready to be charged. Yes, you're authorized to be charged. Go ahead, let's start charging. All of the protocols for communication between a charger and the receiver on the car. We've been working with all the automakers in the SAE committee and other standards groups like ISO and IEC, and in the past 2 years devoting a lot of time in China to what's called a GB standard, which is their standard organization out of the China Electricity Council, to have a China standard, because that market is going electric so much faster than any other part of the world.
Yeah, what happens in China in this market is what happens.
Yeah, I think every automaker is building their EV platform plans around the need to have EVs in China. I think the China government is absolutely gone for electrification, right? It's sort of a done deal. If you ask a consumer in China, are they considering buying an EV as their next car, 90% will say yes, they're considering buying an EV as the next car. If you ask that question in Europe, it's probably around 60-70%. Now, the European governments have mandated very strict carbon emissions rules and with strict penalties. And so the automakers know that they are on a very short time frame to get to 15% plus of the fleet that they sell being electrified.
Right.
So they're pushing hard, and they're investing in the infrastructure to make customers more willing to buy an EV.
To break that barrier.
And I think in the States, the equivalent numbers that I've seen would be about 40-50% willing to consider an EV. That's a lot higher than it was a few years ago. But I think that the U.S. is much more on sort of a consumer choice model, laissez-faire, not that much government intervention. And, if there's a good car that's attractive, that has good specs, features, range, and a nice price, then people will buy it. If it's in the form factor they want, and if there isn't, they'll just keep buying gasoline-powered cars. I think that, that's the mix to EVs is getting better and better each year, but there are challenges, right? We don't buy a lot of sedans in the U.S.
Right.
The market is SUVs now, crossovers,
right? Which are of course
trucks.
Harder to electrify,
right? Well, that's a choice, right? I mean, if a third or so of the U.S. market, is buying sedans, and the only EV you can buy is a sedan, you've basically cut off 60-70% of the whole market. If you're not selling the EV in every state in the country, you're only selling it in 12 states, which is often the case.
Yeah, exactly.
Then you cut off whole portions of the market. So when we talk about the U.S. being at just under 2% penetration of EVs, it's not really a fair statistic. In California, it's like 9 or 10%.
Right. Where the automakers are focused,
right.
Where the dealers are focused, where there's infrastructure, it's
so
higher.
It's very spotty, your ability to buy. I think Tesla has done a great job at a broad footprint, but most of the traditional automakers are just not promoting the cars everywhere there are customers. And I think the shift that's just starting to deliver the first crossovers and SUVs that are electrified, that opens up a whole new set of customers. There are just some people who that's fundamentally the form factor they want to buy. They haven't been able to get one electric yet.
Right.
And pickup trucks.
But there's good reason for that.
Pickup trucks.
Yeah, it's a lot harder to. Not that it's harder, but it's a lot more expensive to provide that battery for a big, heavy SUV or truck.
Well,
so part of it was waiting for prices to drop.
Yeah.
So this is a good moment.
That is true. But crossovers though are
now that we've gotten there with the Mustang, the Mach-E, and the efforts from Volkswagen and all those folks. Audi, excuse me.
Yeah.
With their e-tron,
it's beginning.
That's really beginning,
and I think that's an important part of the story. And so,
yeah, especially for this market.
And that's why I just don't want people to over-rotate on this. Less than 2% are buying EVs today, because I don't think that's an accurate reflection of actual end customer demand.
It's a good point. Not only is the sale limited to certain states usually, but the sales channel. Right, the dealership sales channel, I know a lot of those folks are dragging their feet and not promoting EVs because a lot of their business comes from maintenance. And as we talked about, and just a little bit here, but it's a well-known fact, EVs have around half the number of moving parts as fossil fuel vehicles. They require so little maintenance over their lifetime that a lot of those folks don't really want to lose that side of their business.
Yeah,
keep them in the back of the lot. They won't show you them first. They'll actually, just from personal experience, I know that when you walk into a lot, they'll say, yeah, you can buy that, but there's not much charging around it. That's for a few years from now. That has its effect as well.
Yeah, I think the economics of the whole industry are being impacted here.
Yeah.
Just this week, there was in fact, I think it may just yesterday or the day before, there was an article that came out that said that there are over 400,000 powertrain jobs in the German auto industry that are at risk over the next 5 years.
Mm-hmm.
That there just it's just not as complicated to build, not as many parts. And in fact, we had one conversation with one of our German automaker customers that said, could we build your wireless chargers, in our factory in Germany? And I'm totally open to the conversation, but it just reflected that they're all really trying to figure out, what do I do with all of our employees when we aren't building that many engines?
Yeah.
And in fact, many of our tier one customers, so tier ones are the suppliers that supply to automakers. Their parts go directly onto the factory floor of an automaker. The tier ones in many cases are having to find sort of new areas to branch out in electrification as they see their pistons and valve train and components for engines starting to mufflers.
It'll be the same for lubricants,
all of
engine sludge cleaners.
So it's a big shift. I think that one of the probably unsung smart thoughts or strategies that companies like Tesla in rethinking how to sell cars in this EV age was that typically one city has like one service center, maybe one or two service centers, as opposed to every single dealership location having its own service center.
Yeah.
In the end, that may be the smart move because there just isn't that much to surface. And
It may be, and the other thing the other advantage they have being a newcomer is they don't have those hundreds of thousands of employees that are in the legacy business. They don't have to fire all their engineers and manufacturers. They just don't hire fossil fuel powertrain engineers. They sort of have that newcomer advantage, not this legacy they have to overcome. So there's all these human factors, far beyond the technology.
Yeah, no, there are, and I think it is it's a challenge that the technology starts to look a lot more like any other electronics device with a completely rethought supply chain.
Right.
And probably the other thing that's weighing on the companies is the push to new electronics features in general. Autonomous development has proven to be very, very expensive.
Yes.
I think it is a really important part of the future of mobility, right? I think that there are two elements to it. One element of autonomy is just driver and passenger safety, and the application of autonomous technology today to in braking systems and collision avoidance and warning is really fantastic, and in fact is truly saving lives right now. I think the sort of pure autonomous, the car will take you anywhere you want to go anytime, is proving to be, it may be too strong to say elusive. It's just I think it's taking a little longer, or will take a little bit longer than people have proposed, outside of sort of targeted areas or neighborhoods or
well mapped, geofenced, right, well trodden paths.
But I do think it's going to happen, and I think that it will dramatically, if you combine it with electrification, dramatically reduce the cost of transportation per mile,
but also change the whole industry.
Well, and I can tell you that when we talk with our automaker customers, half the conversation is about what I described earlier, making charging simpler and easier, and EV ownership a better experience. But the other half of the conversation is setting a foundation for a future that's autonomous, right? So if you think about those autonomous vehicles, there's no one to plug them in, right? You think about the development in energy, even advertising that goes into like auto parking, like my car's going to go park itself in the garage.
Yeah.
Well, that doesn't work if it's plugged in, and the cars can't plug itself in. So all of these user experience, what we refer to as sort of auto valet, all the way up to the future of robotaxis, all have wireless charging as an essential feature.
Right. Unless you want a crew of folks running around the garage, plugging in, plugging out. But
you really, from an opportunity charging point of view, like I'm in the urban district, I'm serving this neighborhood, I'm between rides, I just want to top off for 10, 15 minutes. Wireless charging.
Right. It has to be wireless. Solution. It just has to be. So the automakers see this.
Yeah, and so
those two trends are coupled.
It's our future, but we're not leaping directly to that because just those cars aren't ready.
Yep.
So we're setting this foundation for that by broad adoption.
Mm-hmm. So you mentioned robo-taxis, and that ties into the angle here around commercial use cases and why wireless is such a good option for the commercial space, delivery fleets, etc. So can you maybe speak to that?
Sure. There's a few. Well, one is just the fact that you are going on a regular route to regular destinations. You have dwell time, like at a loading dock, for example. With wireless charging, just when you pull up to load and unload, you can be charging, you can be topping off the battery. You don't have to think about it as your full kind of charge. You don't have to think about it as being, what you might do overnight. It's opportunity charging, and what happens is that you can get so much range extension that a car or a van or a vehicle or a bus that might have had to have been taken out of service to go, off to be charged, can now actually complete its full day of tasks by having periodic, brief opportunity charges.
Right. And that also allows a smaller battery in the first place.
It could either allow
that's
a
how you
smaller
want to
battery,
play it. Yeah.
or it could allow you to extend the effective range of the vehicle.
Right, whatever you need.
So, for example, there's the active deployments of our technology for buses, for electric buses. And I was just at a very large installation of wirelessly charged electric buses out in California, and there is at the end of the route, at both ends of the route, where there's a driver change and or just a driver break for 10, 15 minutes. At that parking spot or that bus stop, passengers get on, get off, but the bus is being charged at 250 kilowatts of power. And in that time, it's charged enough that the bus can be on that route, could be on that route effectively 24/7.
Nonstop.
You would not necessarily have to take it back to the bus barn overnight to charge it.
Wow.
Right? You could just go and the battery of the bus basically goes through this periodic charging, gets topped up a little bit, and then obviously it does its route, gets topped up a little bit, does its route. From the first shift in the morning to the last shift at night, it's been able to stay en route. You haven't had to buy another bus to replace it because it doesn't have to go away for a few hours of charging. It can stay there. And so the battery itself stays within its most efficient range, right? So you're never driving the battery all the way down to zero, which damages battery's life.
Right.
You're never having to charge it all the way to 100%. You can stay between 20 and 80%.
The optimal range.
The whole day.
Yeah.
So you can improve your battery life, which is the most expensive thing, on that bus. And you can make it through the whole day. And the drivers are never having to deal with cables and cords, and there's no threat of vandalism or stealing of all that copper. And there's a whole bunch of, the drivers can just focus on passengers. They don't have to think about any other task. That's also very important to a lot of unions as well, that the driver isn't burdened with other tasks and dealing with high voltage cables and such. So
right.
There's there's a complete model here.
A lot of dimensions to this,
right?
Yeah.
Of why this is really a very, I think, a critical technology for broad adoption of electrification of buses, and a very clear total cost of ownership play. And so I think when you come to any commercial application, getting electric, adding wireless charging so you can complete all your rounds and do opportunity charging and make it through the whole day and not have to buy two vehicles for what otherwise would have been one vehicle's task. All of these things, and as you said, maybe even as you tune and refine this, maybe and decide, maybe the battery doesn't even have to be that big.
Right. Which again is the largest part of the cost.
So there's a whole element of total cost of ownership here, and you could buy one infrastructure that can work across many, many, many vehicles, right? So it's an exciting opportunity for us.
So that's the fixed route part of it. So that, of course, involves the opportunity charging. But then you have, say, delivery. Now, for delivery, they mostly are going to rely on depot charging. But this technology even makes that easier, right? Because the catastrophic event is one driver drops off the delivery van at the depot, forgets to plug it in. The next day, that whole truck can't work its shift.
And we've had that conversation. It's basically the fleet problem, right? So as fleets shift to electric, and this could be, this could be 100 cars used by meter readers, right? Or traffic, policemen who are going around, giving out parking tickets, or any electric meter readers, gas meter readers, any sort of fleet, police cars, whatever. The fact that you need all those vehicles to be 100% available for the next shift. And we spoke to one fleet operator who said about 10% of the drivers were not remembering or bothering to plug in.
Right.
And then that vehicle is just out of commission for a whole shift.
All the capital costs is sitting there.
Yeah, right there.
Yeah.
It's dead. So that is a great application for technology. There's a similar application that has actually already been deployed by one of our customers in China, is ride sharing, or really these car sharing services.
Here like a zip car.
Like a zip car, right? And so BMW was one of the first companies to introduce our technology. They came out with a 5 Series BMW with built-in wireless charging, and if you want to see it in action, there's a great YouTube video. If you just look up BMW wireless charging, you'll see. But they equipped a whole parking garage in China with these BMW vehicles, which are used as part of a car sharing program, which was Ride Now in China.
Right.
And the beauty of it is that every time you walk up to the car, it's charged, right? And that the prior user of that car didn't have to take any action or do anything. So as we try to bring that more and more of the vehicles electric, that again, wireless charging fits into it. I also think that this commercial application is important for taxis, right? For taxi fleets need to electrify. The urban environment is where we most need to get pollution, out of the urban environment. And taxi drivers have a lot of anxiety about shifting to electric because the time that they're charging is time that they're not, getting rides and generating income. One of the things that we can do with WiTricity's technology is enable queues. So everything I've talked about so far was this idea of park and charge, but our technology also lends itself to dynamic charging, the ability to actually electrify a strip of a lane with wireless charging capabilities. It was demonstrated that that this was possible up to 100 kilometers an hour, over 60 miles an hour, that you could deliver full power to a car in motion. I think that it's a really kind of beautiful idea and very appealing that that you could have wind and solar distributed along highways and have power lanes that you could drive along without using up any of your battery capacity. Technically, absolutely possible.
Right.
Economically,
maybe not.
I don't know that ripping up 50 kilometers of highway is going to be that practical soon. Maybe in China with the massive infrastructure investments they make, but probably in the rest of the world.
But for a taxi lane, for a taxi queue
doing
at the airport,
doing 100 feet, doing 100 yards, 50 yards of a taxi queue at an airport or at a train station, is absolutely practical. And so again, that's not something you can do with a cord, right? You just can't do it. You need to pull in the lane, and you need to be inching forward a couple of feet every minute, and the whole time you're in that lane, you could be charging your vehicle. So I think again, WiTricity's technology, has really critical role in getting these key parts of the transportation infrastructure electrified.
You also mentioned, the urban challenge here. I mean, where urban use cases are calling for electrification the most. And there's a great synergy there because with the particular characteristics of EVs, they're actually best suited for urban driving as well. They don't really idle. Of course, regenerative braking means they take advantage of start and stop.
That's absolutely right.
Noise pollution is a problem in cities. There's almost no noise. Of course, air pollution, and then greenhouse gases are an issue everywhere. And there's more than what I just mentioned even, as well as instant torque at low speeds. So there's a great alignment there. And so everything we can do to make that easier, that urban adoption is an excellent direction to go.
So it is this almost a perfect storm, right? That the absolutely most apt use of an EV is urban, yet it presents the most challenges for charging and charging infrastructure. I spend a lot of time thinking about, how is our technology going to roll out and get to market? And I think that for EVs in general, the urban buyer is probably the most challenging one to get to, even though the demand is there. Our technology is going to roll out first into people's garages, right? It's going to roll out where you own your own garage or have your own driveway. And when you buy the car, you're going to get a charger. It'll come from the dealer, be installed by your electrician, just like installing a plug-in charger today.
Right.
That's how kind of it first comes to market. We already have what you'd call sort of VAR or installer relationships for going into parking garages. So now I'm shifting to sort of like the apartment dweller that has a parking garage to be able to install in your parking spot in the garage, or for the landlord to install several chargers in the garage. And so that's sort of the next phase, and that constitutes a large portion of car owners. But like I grew up in Manhattan. I grew up in Lower Manhattan. I learned to drive in New York City. My dad used to send me out at night to go move the car because we had alternate side of the street parking. Like I'm a street parking. It's in my blood. That is a problem I want to solve eventually. I don't think that we can practically get charging infrastructure into the parking spot on the street until we have enough density of cars out there that have our technology. But I do believe that ultimately we will get there, because the idea of wireless charging embedded in the street, it is one of the benefits of our technology, is that we can actually be in the cement and in the sidewalk, in the pavement. That there's no cables, there's no mess, there's no clutter, there's no intrusion upon the sidewalk.
Nothing for the snowplow
nothing for the snowplow to nick.
And
there's no big, thick, expensive copper cables to be stolen. Right? Is sort of vandalism proof. So I think that ultimately we'll get there. But I always think of like, how do you get there from here? That will take a while.
Sure. So I did want to ask about next steps for WiTricity and rolling this out. So, you mentioned you're working with the automakers, of course. I'm sure some of this you can't quite talk about, but what can you tell us about coming deployments or deployments you're really excited about for the near future?
So we have, I can't name specific customers. I mentioned earlier that BMW has already launched our technology. They did a pilot launch of our wireless charging in Germany, in California, and in China. So it was a pre-standard, right before this global standard has been ratified, and a first sort of taste of what was possible. Great customer insights coming out of it. We have multiple global automakers rolling out over the next few years. I think you're going to see the big push in 2020, end of 2021, and really in 2022. The automotive development cycle is relatively long,
arduous.
As a sort of personal computer guy for most of my career, where we got to the point you could do 3 complete product line launches in 1 year, I've now had to flip to doing a product launch every 3 or 4 years. It's a very, very different world, but that's what comes with the commitment to design the technology into the platforms and have it be certified and rolled out globally by the automakers. We have had some public visibility. Hyundai demonstrated our technology at the Geneva Motor Show 2 years ago when they launched the new Kona. We have a very active program in China. As you said, even you said earlier that everything electric kind of has to have China growth as part of their key strategy. We as well have a team there and are embedded in the China National Standard, our intellectual property, and we have licensees there, and they're making a big push for the Beijing Olympics. So I think 2022 is going to be a big year for wireless charging, for us and for the industry.
Well, that's great. And I guess just the last point, you're really emphasizing that you want this technology built into the vehicles. You don't want an aftermarket, hack, as you said, or some kind of a third-party add-on. Why are you going that route despite all the extra difficulty? What are the benefits?
Well, I think that the user experience is paramount, right? I mean, the fact is that you're dealing with very high voltage systems. This is, you're plugging into what are the sort of fundamental power architectures of these EVs, right? So it's not just it's not just a little extra feature. It is the feature of that EV, that powertrain. We're plugging directly into the battery management systems and being controlled by the batteries, say what voltage to deliver to that battery. So I view it as really critical that we get designed in. And the car's optimized, that we have the right space and location, that the user feedback comes right through your dash that tells you that you're parked in the right spot. It's just sort of a total, integrated solution, and that has both brought us completely into the development model with the OEMs, the brands, and their tier ones, but also means that when we're designed in for a long time. All right, so it's about getting to these first launches, and we're sort of all out getting towards getting these first deployments. it's it's exciting. It's forcing us as a startup in the Boston area to bring in a lot of automotive knowledge to deliver software and firmware that meets all the automotive standards and certifications. It means our team is in Detroit, our team is in Japan, our team is in South Korea all the time, our team is in China. We have people on the ground based in China working with the automakers. So, we're this relatively small, in probably automotive terms, startup in the Boston area, but we're operating as a global automotive technology supplier. And part of the way that we've come to this position is by building an extraordinary IP portfolio and know-how and knowledge and experience. And we've been building these solutions for nearly 12 years now, right? Incrementally improving the technology. We have now over 900 patents issued. We have we have another 500 or so pending. So all in all, our IP portfolio, which includes all the real essential IP in the space, is now over 1,400 patents and applications. It's kind of all roads sort of lead through WiTricity. A year ago, I acquired Qualcomm Halo, which was one of the other participants in this space. We were both pursuing customers. We both had IP portfolios. As I spoke to automakers, there was a lot of confusion because, should we go with WiTricity's architecture? Should we go with Qualcomm's architecture? There was confusion around IP and which portfolio did I need to license? Did I need to license both? In fact, the example I gave earlier, BMW, that launched wireless charging, had taken a license to WiTricity's portfolio and to Qualcomm's portfolio. And
just to be safe.
Yeah, and that was providing anxiety for the auto industry. It was like, well, all right, do I have to do both? And so a year ago, I acquired their business. And now we merged in Qualcomm Halo with WiTricity. And so now we're able to, at lower cost, license one complete portfolio to every automaker or tier one. And we're able to simplify the design, sort of take the best of both teams and present a much simplified approach to the global standards committees, which has accelerated ratification of the global standards. So for me, it's just like we're all in on this. We're completely focused. And we've got the most experienced team and know-how and all the IP, and we're just marching ahead as fast as we can.
So it seems like you guys are ready to take over the world, huh?
Well, it's a long march.
Yeah,
it's a slow.
It's a complicated
thing in the auto industry, but step by step, we're absolutely getting there.
Well, that's great, and hopefully you can reduce some of the barriers to EV adoption and actually make it more convenient for people than a fossil car.
That's my goal. I mean, whenever I meet someone and tell them what I'm working on, no one has ever said anything but like, wait, I want that.
Yeah, it just clicks.
How soon can I have that?
It just clicks.
So that's what keeps our whole team excited and motivated.
And it's the same thing on the commercial side as well, which is a huge part of it. So, well, hey, Alex, we really appreciate you joining and telling the story. We wish you guys success, and we hope you're a key part of this industry that we all need it to really take off.
Well, thank you, and appreciate your help in spreading the word about what we're doing to make wireless charging broadly available, and to just make the ownership experience of an EV just that much more pleasant.
Hey, it was our pleasure. Thanks a lot.
Thank you. Bye.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.